Alright, welcome back everybody. In example 4 of the chain rule part 2 lesson, we're going to find the value of various derivatives numerically based off of a table of data values that we have about the two functions f of x, g of x, and their derivatives for various values of x. So we're going to be finding the derivatives of these. So for part A, we're going to find the derivative of f of x plus g of x at x equals 4. So first I'm going to take the derivative of f of x plus g of x. Using the sum rule, that is just equal to the derivative of x plus the derivative of g. And so to find the value of this at 4, I'm just going to take f prime of 4 plus g prime of 4. I'm going to go ahead and look those up on my table. F prime of 4 is right here, negative 4/5. Oops. And g prime of 4 is right here, negative 1/3. And so I'm going to add those two together. Let's see, that's 15ths. It's negative 12/15 and negative 5/15 gives us negative 17/15. Or for those of you who like decimals, negative 1.13 with the 3 repeating. Alright, on to part B. In part B, we're finding the derivative of f of x times g of x at x equals 1. So first I find the derivative of f of x times g of x using the product rule. That's going to be f of x times the derivative of g of x plus g of x times the derivative of f of x. And we're going to find the values of all of those at 1 in order to answer this question. And so we're using this whole column right here to answer this question. So we need f of 1, that's 1/3. And g prime of 1 is 2/3. And g of 1 is 1. And f prime of 1 is 5/3. And so this ends up being 2/9 plus 5/3. I convert those all over to ninths. It's 17/9. Or for those of you who like the decimals, 1.8 repeating. Alright, on to part C. In part C, we're going to find the value of the derivative of f of x over g of x at x equals 0. So first we're going to take the derivative of f of x over g of x. So we've got low times the derivative of high minus high times the derivative of low all over our denominator squared. And we're going to evaluate this at x equals 0. So I want g of 0 times f prime of 0 minus f of 0 times g prime of 0 all over g of 0 quantity squared. I'm going to have to scroll back and forth up to my table here to gather these values. We're looking for all the values in the 0 column. So we're looking for these values right here to answer this question. Alright, so let's see, what do I need first? I need g of 0, that's negative 2. Hope I don't make anyone nauseous with all my scrolling up and back for these values. F prime of 0, which is 3/2. F of 0, which is 1/2. G prime of 0, which is -1. And then I need g of 0 squared in my denominator. Alright, so let's see what we've got here. We've got -3 plus 1/2 all over 4. It's -5/2 over 4. Or -5/8. For those of you who like decimals, -0.625. That's going to be the value there. Alright, and the last one we're going to find, excuse me, we're going to find f of the derivative of f of g of x at x equals 3. And here's where we need to apply the chain rule. We're going to take the derivative of the outside, leaving the inside the same, times the derivative of the inside. And we're going to find the value of this at x equals 3. So we want f prime of g of 3 times g prime of 3. So first I need to go up to my table and look at the values for g and g prime at x equals 3. So I need g and g prime at x equals 3. Okay. G of x equals 2, g prime of x equals 3. So this becomes f prime of 2 times 3. And now I need to look up the value of f prime of 2 from my table. F prime of 2, right here, 1/4. So I'm going to substitute that in. And we end up with our value for the derivative, or for those of you who like decimals, 0.75. Alright, and that's it for example 4. Just wanted to go through a few more examples of finding derivatives numerically, symbolically, based off of a table of values in this example, so that hopefully if you encounter a few more of those, you're a little better prepared. Alright, that's the end of this video and the end of this lesson, and I'll see you guys next time. Have a great rest of your day.